I'm a geologist. One of the questions that I'm interested in has to do with earthquakes. How often do they happen along particular faults, and how big are they when they do occur? The answers to those questions can help people prepare for such an earthquake and reduce the risk that they face. How do I address those questions? I make a lot of detailed observations of the fault and the surrounding region that I'm interested in. For example, I collect detailed topographic data and map the places where the fault meets the surface. I might dig a trench across the fault and look for evidence of past earthquakes. I collect data that can tell me how old the fault is. Then I put all of those observations together to estimate how frequently major earthquakes have happened on that fault in the past, and use that information to make a prediction about what we might expect in the future. Scientists in lots of disciplines collect observations from the natural world in order to address their research questions. Astronomers seeking exoplanets, those are the planets that orbit stars outside of our solar system. They select sectors of the sky to study with high-powered telescopes and look for changes in the brightness of stars as planets pass between them and the Earth. Climate scientists, they extract ice cores from glaciers to measure greenhouse gas concentrations in trapped air bubbles. Biologists, they count and track reintroduced species like condors and wolves. Ecologists, environmental scientists, oceanographers, meteorologists, while the thing they observe may be very different, they may go back into the past or may be only about the present, scientists in all of these disciplines use detailed systematic observations and descriptions at the heart of their research. Sometimes detailed observations lead to questions. In other words, sometimes scientists might have an idea that something is interesting, and they start collecting observations before they have formulated a research question. Curiosity about what's out there lies behind projects like launching the Hubble Space Telescope. If we get a better view, more details, we'll be able to ask better questions. Sometimes, detailed observations made for one purpose can lead to research questions with totally different purposes. For example, the search for the lost Malaysian air flight in the Indian Ocean prompted detailed mapping of the seafloor. When those data were released, scientists were able to observe evidence for processes happening to form new seafloor that hadn't been observed before. Sometimes, scientists enlist others, what we call citizen scientists, to help in making detailed observations in order to cover more ground or collect more data. A great example of this is the Great Backyard Bird Count, run since 1998 by Cornell's Ornithology Lab and the Audubon Society. In 2016, over 160,000 people from around the world submitted their observations about the birds they saw and counted over a 4-day period. These data create a big picture of bird migrations and population dynamics that would not be possible for a single scientist to develop on their own. Scientists recognize that systematic, detailed observational datasets have value beyond their original purpose, and many datasets, especially those that are government-funded, are available for anyone to use and analyze. These include things like a global earthquake catalog that spans the 1990s to the present, streamflow measurements from around the United States, and measurements taken from ice cores taken around the globe. Many scientists use these datasets as a starting point for a new research project or as a way to compare their own observations with a larger database. For you, taking a look at these freely available datasets could also be a great way for you to get started on a research project of your own.